This module is looking at the measurement strand of the curriculum, and the measurement strand of the curriculum is exactly what it says. We are measuring different attributes. One of the things that you need to do in this module is understand the sequence about the teaching of measurement. In the early years of schooling, we're very much about developing a sense of whatever the attribute is, whether it's length or area and so on, and how we go about doing that, but also starting to get the children to develop measuring techniques for the different attributes as well. On the course side, there's an informatic, which would be, it's highly recommended that you read that or engage with that. So in terms of the measurement strand, there are a number of key areas within this strand. First of all, we generally teach the length attribute, probably the first of all of the attributes. So the length attribute is about finding the distance from one point to another, which is usually in a sense a one-dimensional length, or a two-dimensional where we're looking at the perimeter around an object such as a square or a paddock or so on. Then we have area, and the area is the notion of covering, and that is how many units are needed to cover or to cover the enclosed shape. And we will use very different shapes. We'll start off, as we usually do, with some of the very basic shapes such as squares and rectangles. Circles, of course, are a quite unique area of measurement. We tend to leave those until a little bit later because it's harder for the students to work that one out. Coming back to the first lecture, where we talked about the different things that you would be focusing on in the early childhood years, is one of the things is about making connections between different parts of the mathematics curriculum. And here's an example of what you might do, is looking at the relationship between area and perimeter, and I want to come back to that one in a minute. But connections are again very important. We might be looking at the volume of particular solids. Now you'll see I've used a very different term here. When I was talking about area, I was talking about shapes. When I'm talking about volume, I'm talking about solids. Often people will use the word shape interchangeably, and you can do that, but it does create problems for learners. So coming back to our session on language, here you start to see how language can create difficulties for students. If you're talking about the area of shape and then the volume of shapes, that's creating a potential conflict. So if we are very clear about the language we use, so what we do is we tend to use the word shapes to refer to two-dimensional things and objects to refer to solids to refer to three-dimensional objects. We look at mass, which is the often it's used interchangeably with the concept of weight. They are, however, different. And one of the classic examples is weight is very much dependent on gravitational force. Not that you would work that with children, whereas mass is not so. If you go to the moon, where the gravity is only 1/10 of Earth, your mass will still stay the same, but your weight will be only 1/10 of what you are. So these terms, in the everyday context where gravity remains constant, they are, for all intents and purposes, the same, but in a truly mathematical context, they are not. So it's important that you know those differences. We'll also be teaching about time, and there's two aspects of time that you need to be aware of. There are points in time, so these are things like Monday, Tuesday, Wednesday, or the months of the year, or 3 o'clock or 4 o'clock. So naming a particular point in time, or we're looking at the passage of time. So what might a year be? What might a second be? What was the time lag between this time at 9 p.m. and 3 a.m. How long was that? So we're looking at two different aspects of time. And the other one that we look at is money. And money is about the socially recognised value of objects, and it is a very subjective thing. You'll know that some people are quite prepared to pay, I don't know, $400,000 for a Lamborghini. Other people would say, well, that's not value for money. I prefer my $20,000 Hyundai. So money is a very subjective area, but there are parts of it that in our culture we see it as an important placing of value on objects. So there are areas of measurement that you will cover. We start off, particularly in the early years, with working with the concept of length and a little bit of area. So I want you to think about this puzzle. And again, this is coming back to our problem-solving context. Sure, this is not something that you will do with your young children, but it's something for you to think about. So if the perimeter of a regular four-sided shape, such as a square, remains the same, will its area also remain constant? Now that's a problem that I would like to leave with you. You may want to talk about it on your discussion board, or if you've got someone close to you that you can talk this through. This is a conception that people have, that if the perimeter stays the same, so if you've got an object and the perimeter is 16, then the area, what will that be? I want you to think about that one and follow up on discussion board if you would like to. Now, when we're coming back to teaching the measurement strand, we've been talking through this course about using a problem-solving context. I want you to think about two ways that you could teach area. One of them is the one you may remember, and that's about giving the students a formula, length 2L plus 2W. No, area. We're looking at length times width, sorry. Looking at length times width, and then you just plug in those figures so you can calculate out what the area is. A second approach is about getting the students to generate their own formula. Getting them to understand that area is about length multiplied by width. In this context, I would like you to now start to think about, we've covered quite a lot of work to date in this course. I want you to draw on what different theories might underpin these two different approaches and the different methods that are being used. So what are the two of the theories? I could actually say there's probably a few more theories in there. So what are the theories that underpinning these two approaches to teaching area, and how are they evident in these very disparate approaches? These are the types of questions that you need to start to become quite clear about in terms of, as we move towards the final assessment in this subject, you need to be quite aware of we're going to start making connections now between different parts of the course in terms of problem solving, theories of learning, and now a particular area of the mathematics curriculum. If you'd like, we can use the discussion board if you're struggling with some of these ideas. So we'll finish on that note. That gives you something to think about and starting to draw elements of the course together. Finally, and this is in your informatic that you need to start thinking about, the informatic will take you through this in much more detail. So here is our teaching sequence. We first of all the children need to identify whatever attribute it is. So if it's length, they need to be able to articulate that attribute and separate that attribute out from colour or shape or any of the other attributes that are there. The students are then expected to compare two objects and say which is taller, which is shorter, and then we introduce the third object, and then they're starting to put those into order from tallest to shortest or shortest to tallest. It doesn't really matter unless you've made a specific comment of which way you'd like it. After that, the students are comparing against each other. We then introduce informal units of measure, and these are things like paper clips, building blocks, MABs, anything that you've got in your classroom. So the students start to develop principles of measurement. So they know that they must put the block or the pencil clip, the paper clip, or whatever it is at the start of that object, not halfway through. They need to know that the units need to be touching each other. They need to know that they're end on end. So they're starting to develop principles of measurement as well as counting whatever those units are. From here, we then start to introduce the need for formal units, because you can't compare if you've got the same object and you've measured it with books and I've measured it with pencil clips, paper clips. My paper clips are probably going to be about 30, your books might be 3. How can we compare which is longer, which is shorter? Because we don't have a common unit of measure. So we'd start then using the same object, such as books, and then we're formally introducing, when I say formally, I'm meaning through a problem-solving process, the need for standard units of measure. In this case, centimetres or metres, so that students know. Part of the formal units of measure also becomes selecting and identifying the most appropriate unit of measure. If you were measuring the length of a book, would you use a metre ruler or would you use centimetres? So that's really important. And finally, once the students have started to use and are very familiar with the use of formal units of measure and the principles of measurement, we then start to make applications. So here comes our numeracy into the curriculum and our problem-solving context as well. So please refer to the informatic for more information on that.